Voila, it's 1 o'clock in the afternoon. We already have around 50 participants, so welcome to the Mutation seminar on the origin of grape varieties. We are very happy that we have José Vouillamoz engaged, a grape variety researcher and DNA profiler on this topic. And we're really overwhelmed about the interest for these topics. And it seems that we've chosen it wisely because it's to some extent a dry topic, and we got registration for around 80 to 85 people and already 51 participating. Normally, when we speak with clients, we talk about the flavor we have in the glass, about the vintage, from which origin the wine is coming. Sometimes we talk about the ageability of a wine, but rarely we dive as deep as today on the origin of the grapes. For the seminar, given the huge amount of people participating, all your mics were muted from us, and please keep it muted during the presentation. If you have very important questions, use the chat function. I can already see that a lot of you using it to say good morning from Belgium and the Netherlands and Austria and wherever you are. And I will collect these questions, group them and ask them to José. But more important, after his presentation, which should take around 45 minutes, José will be available for the Q&A session, where you then can unmute your microphone and ask questions. But if you would do it right now, maybe then the full presentation would last 1.5 hours. And I'm always quite strict that we keep this 45 minutes. José is working in the field of molecular studies of grape destinations since more than 2 decades. He's an independent wine writer and wine educator and vice president of the Académie Internationale du Vin. He has published and co-published several books, and his latest book was called Wine Grapes, which came out 2012 on this topic, and this covers more than 1,300 grape varieties. So you can see, given all your interest, maybe for next year we have some other grape varieties we could bring on stage. José, welcome to be available today and being with us in Switzerland. And maybe now let's start to unveil the unknown facts about Chardonnay and Pinot Noir.
Thank you. Thank you very much for this kind introduction. Thank you, Bernd May, for inviting me for this seminar. Thank you, maywines.com, for making it possible. Thank you also to Brigitte Riener and all your team to set this up and to make all this possible. It's a great pleasure for me to be with all of you this afternoon. It's a bit strange to see only screen faces. I hope that we will soon have the opportunity to meet at a real conference, real seminar, where we can not only talk about grapes and wine, but toast with real wine glasses at the end, because that's what we are passionate for. And for now, we do it online. As it was said, I will be available after the presentation to answer some questions. We start this first session on 2 important grape varieties, Pinot Noir and Chardonnay. So I will share my screen. By the way, I have some workers in my building, so if you hear some noise, I apologize, should not be too problematic, but at least somebody is working in this building except me. So I will start by sharing my screen now. And you should all see properly. Bernd, is that okay?
Yes, it's okay.
Okay.
You can see it.
So, Zoom seminar for today for maywines.com about Pinot and Chardonnay. I not only want to speak about these 2 grapes. The presentation will not be too technical, don't be afraid. You don't need to be a geneticist or to have a PhD degree in biology to understand my presentation. It's made for every type of audience. But before I go into the knowledge of these 2 grapes, I want to introduce you to some other concepts which might sound easy, like what is a grape variety? And you will see that the answer is not easy. Very simply and very briefly, I will show you how DNA profiling and parentage analysis do work. As you see, it's not complicated. If it was complicated, I could not do that. So you see, it's easy. But before that, just an advertisement slide, but most of you know that I'm one of the 3 authors of this reference book, together with Geneticist Robinson and Julia Harding, both Masters of Wine. We published this book in 2012, and I wanted to make this slide to make people know that, yes, we have 2 different color editions, but the content is the same. On the left-hand side, I have a special tool. I love it. It's fantastic. So this one is the European version. This one is the United States version, but the content is the same. And the book is 3 kilos and 70 grams. So journalists and even myself or geneticists could not carry it around the world all the time we traveled. So we released ebook version 1 year after, in 2013. We have won most of the major wine book awards for this book. And in 2019, it was published in Japanese. I should add the image next time. It's really beautiful to see. So enough for advertisement. Back to the topic. What is a grape variety? This question sounds simple, but you'll see the answer is not simple. We start in the middle here with one single grape seed. This grape seed grows into a plant. So I could not illustrate it, but just keep in mind, to have a grape seed that is growing into a plant, you need some parameters. You need this grape seed to not be harvested and turned into wine. Otherwise, it will never develop into a plant. So you need this grape seed to either not be harvested and fall on the ground, or to be eaten by a bird, for example, and defecated a little bit further, and then this grape seed can germinate. When it germinates, it grows into a plant, and this plant must not be torn out. It must not be eliminated by the growers. If this happens today, it would be cleaned up by most of the growers, because we like to have regimented vineyards with perfect lines that we can go with machines inside. So if one grape seed falls in the middle, today it has no chance to survive. But until the end of the 19th century, most of the vineyards were planted, in French we say en foule. So we had different varieties in the same vineyard and a little bit randomly planted. So if one plant would be in the middle, it would not be torn out. The second step would be for the grower to notice that this plant is interesting. Many of them were rejected, but if one plant is interesting, they will want to propagate it. So the grower say, oh, I want more of this plant. So if you want more of this plant, you use cutting. So you cut branches and you plant them in the ground, like gardeners do with any other plant. Or you use layering, which is a technique that is also known to gardener and that the grapevine itself is doing in nature. So you keep the branch on the original vine, you curve it, you plant in the ground, and it develops into, we say mother plant and daughter plant. I don't like this appellation. It's not mother and daughter. It's the same plant that is continuing. And what we're doing by this, we are doing vegetative propagation, which means no sexuality involved. And we are doing what we call cloning. People don't like to hear this bad word, cloning, but that's what we've been doing for 10,000 years by propagating the vine. And when you do so, either by cuttings or layering, if you do 10 times, okay, but if you do 100,000, 1 million, several million times for plants like Pinot, for example, that is existing since 2,000 years, you have the risk of accumulating accidents, of accumulating mutations, because there is no sexuality involved so far. But when you take a cutting and you put it in the ground to develop, the plant needs to have growing and needs to have cell divisions. And for each cell division, you have a risk of the machinery not working so well, and mutations can appear. Mutations can appear also from the environment, that is called epigenetics. This is another topic. It would deserve a full conference, but you have variations. Some of these variations most of them go unnoticed. If this mutation falls in a part of the DNA that has no spectacular effect, nobody will notice it. If it falls in, for example, an enzyme that is missing, it will change the biochemistry of the plant, but most of the people would not notice it. When it is spectacular, so when the leaves are bigger, when the bunches are bigger, when the color is different, we see, oh, wow, that's special. I want to set it apart. And that is what we call a clone. But a clone is a human concept. It's only what we, with our human eyes mostly, are capable of identifying as different from the original vine. And all of these clones grouped together constitute the grape variety, the grape cultivar. So the older a grape cultivar is, the higher the number of clone is. And don't forget that at the origin of all of this, we have a grape seed. What is a seed? In any plant, a seed is the result of sexuality. And here on top left, you have sexuality. You have one plant that is a father, one plant that is a mother. We have both stamen and pistil in each of the cultivated varieties. So one can pollinate the other or vice versa. This is not a big question, but one gives the pollen to the other. This is fertilization, and the seed is the result. So every time you plant a grape seed, you plant the next generation. So basically, if you think of how many grape seeds are produced every year in all the vineyards of the world, you could potentially create trillions of new varieties every year, if you want, if you don't harvest anything and you plant everything. Just keep it in mind. And the only ones that have been maintained and selected by human hands are the ones we have today. So in wine grapes, we had 1,000, well, let's say now 1,500 varieties that are cultivated. That's not a lot. Out of the trillions that are possible to create every year, it's not a lot. It's only those that have an interest. Okay, so what is a grape variety? This is the old definition, and I don't agree with that. It says it's a clone or series of related clones propagated vegetatively from a single parent plant. This is monoclonal origin. Or several genetically similar parents, polyclonal origin or polyclonal synthesis. I don't believe in that. For me, a grape variety is only either one clone if it's very young, or a series of related clones, all originating from a single parent plant, then developed from a single seed. Each variety, Pinot, Chardonnay, Syrah, Cabernet, Merlot, whatever you want, is the result of one single seed that has grown somewhere, that was identified by a clever grower, and that was propagated until today. And it's not all the wine professionals have this in mind. So then DNA profiling, how does it work? DNA profiling, it's very helpful in ampelography. Ampelography is the science of identifying the grape varieties. Here you have a leaf on top with all the measurements. You calculate the teeth, you calculate the angles between the nerves and so on. This is ampelography. Ampelos is vine, graphine is describe. But this depends on this development stage of the plant. Sometimes you need to wait for the plant to produce berries. And many of them don't produce any berry until 3 or 4 years, even later. And it depends also on the sanitary state. Here you have one plant that is sound, one other that has a virus, and it's the same. This is Nebbiolo. This is Nebbiolo lampia, and this is Nebbiolo miquette. We have treated miquette against the virus, it turned back this shape. So the shape can be influenced by the sanitary state. And we have more than 5, 6, 8, 10,000 grape cultivars in the world. Nobody knows exactly. So no one can identify them all by these measurements. And DNA profiling is helping a lot to ampelography. So how does it work? It's like creating an ID card or a barcode that you have in the supermarkets for a grape variety. I take a human example. You have a criminal, you have traces of DNA, it could be blood sample, it could be hair bulb, it could be sperm, it could be different things, and you want to identify the criminal. So you look at some DNA regions here. I put 1, 2, 3, 4, 5, 6. These are different specific regions of the DNA. We cannot look at all the DNA. It's too complex, too expensive, and not convenient. So you look at 6 regions, and you have these numbers. These numbers are the measurements, how many molecules, DNA base you have in this area. And you always have 2 possibilities. Maybe you remember at school, for humans and also for the grapes, chromosomes always go by pair. So for one region, you have 2 chromosomes and you have 2 possible numbers for one region. That's why we have 2. Then you have this DNA profile. If you only have it, you can't do anything with that. You need to check against the database. The database of the FBI would be the best informed database if you are looking for a criminal, but if you have usual suspects, it's easier to identify them. And it's an old example, but that's the best one I could find. When they captured Saddam Hussein, they said that they identified him with DNA. So for example, here you see that the DNA of the criminal is 100% identical to the one of Saddam Hussein, while the DNA of George Bush would be different. I assure you, these are not the official DNA profile. I don't have them. I don't have them. But in this case, we can say that George Bush is not the criminal in this case. Then if you have a grape, I do the same. You have an unidentified grape. You have the DNA profile. I check in my database. Could it be Syrah? Could it be Barbera or whatever? No, because the numbers are not working. And if you look at Pinot, they are always the same. So I can tell you, as a rule, 6 to 8 DNA regions. I do 12 to make sure. Statistically, I do 12 to make sure. And I can tell you that what you have is Pinot. So that's how it works. Then I go to my database. This is gathering of 20 years of my analysis and my colleagues' analysis all put together, and you check into this database. For parentage analysis, it's more complex, it's more expensive, and we use the fact that chromosomes go by pair. So either in your DNA or in Pinot or any cultivar DNA, half of the chromosomes come from the mother and half come from the father. So if you look at this, you have the possibility to extract the DNA of the mother, and then you have the child here. I took a human example as well, also an old one. This child is called Diego Jr. The mother, her name is Christina, but usually in humans, the question is not the mother, because we know who was at the hospital to give birth. It's the father that is the question. So again, you can see that in this case, the mother gave the value 182 to the child. The value 174 must come from the father. Here, same, she gave 212, 216 must come from the father, etc. So you can reconstruct half of the DNA that the father must have to be the biological parent. So that's how we do when we have some suspects, and this is, the case is true, but the numbers are not true. Maradona was playing with Naples team in the 80s. In 87, I believe he was winning the championship of Italy. And he had a reputation to go places, you know. And his teammate, Careca, also had this reputation. If you look at this number, 174 is in both Maradona and Careca. This is by chance. You need to go further. And this 216 cannot come from the mother. Maradona has it, Careca no, etc. Then you can exclude Careca, say, you know, you're not the father. And you go, usually you go 30, 40, 50 different DNA regions for statistics. And then you say, okay, Maradona is the parent. So with grapes, we do the same. Here you have Riesling and Silvaner. They crossed it in research center. They called it Rieslaner. And you see that both parents gave one value to Rieslaner, and Barbera could not be one of the parents simply because the numbers are not matching. So also for grape parentage, we do 30, 50 DNA regions depending on the complexity of the question. So I'm done with the kind of technical introduction. I hope that I didn't lose any of you so far. And now we talk about Pinot and Chardonnay. So first of all, the etymology, the origin of the name. This is not rocket science. You can make many hypotheses. And what we have tried to do in wine grapes, and what I try to do usually, is to find the most convincing one. When you think of a grower in the Middle Ages that has to name a plant, it is quite improbable that he would go in very old books in some library and find a fancy name. No, he will need a name to distinguish this plant from the plant of the neighbor. So it's very pragmatic. And for Pinot, there are two possibilities. Either it is because the grapes, and I put it upside down, the bunch resembles a pine cone. Why not? Or there is a little village called Pignols in Puy-de-Dôme in Auvergne that could be its origin. It has cultivation of Pinots in the Middle Ages. So many times you name a grape variety according to the shape or any particularity or the place where it comes from, or maybe the name of the guy who propagated it, which is the case of Malbec, for example. And Chardonnay, also, the most probable etymology is a village. So we are here, we are in southern Burgundy. Here you have Mâcon, then you have Beaune up here, Ouchisy, and there is a small village called Chardonnay where, yes, the grape has been cultivated since a very, very long time. So the most likely hypothesis is the village name. In terms of history, I couldn't see pictures of the original documents for this presentation, but I give you the details. It's always important to see when and where the most ancient reliable mentions of a grape come from. It gives a good idea of where the plant can originate. And for Pinot, of course, we are in Burgundy, where the earliest reliable mention in 1375 was when Duke Philippe le Hardy, he was anticipating his forthcoming trip to Bruges, and he was very clever because he wanted to have wines over there when he would get there. So he sent, I read it in French, 6 queues et 1 poinçon de vin de Pinot Vermeil. So queue and poinçon are measurements of volume. So the total I've been said is 25 hectoliters. I should do the same when I go for vacation. That's good. And Pinot Vermeil, Vermeil is red, light red color. So we know that he was talking about Pinot Noir wine. This was a finding we did for wine grapes because before that people were always saying that it was mentioned in 1394 under Pinots, but for wine grapes, we found this oldest mention. It was also mentioned later in Germany, under Klebrot in Switzerland, under Salvagna in Austria, and under Blauburgunder, and so on. So it gives you an idea of the past distribution of this grape that we find today all over the world. Then also interesting, the spelling Pinot. was established in 1896 at a Congress, because we used to write it PINOT or OZ or PINEAU, but to distinguish from Pinot Doni in the Loire, it was decided to call it Pinot, P-I-N-O-T, from this date on. Chardonnay history is a bit shorter. You will see later why. The earliest reliable mention is at the end of the 17th century under the name Chardonnay in Saône-et-Loire, which corresponds to the region where it has been historically cultivated. Until the end of the 19th, early 20th century, it was very often confused with Pinot Blanc. And many times when you read old books, you read about Chardonnay Pinot Blanc or Pinot Blanc Chardonnay, which is confusing. We never know when we are talking about the real Chardonnay, when we are talking about the real Pinot Blanc. And these grapes that have been around since a long time have a lot of different names. According to the place where it has been propagated, where it has been transported, the names can change. For example, I will read it with you rather quickly. In Austria, it's Blauburgunder, like in many other regions. So the blue from Burgundy, simply, or Spätburgunder, it's late ripening from Burgundy. In Steiermark in particular, it's called Klevner, as well as Alsace and other regions. In France, it has many different names, like in Auvergne, we call it Bourguignon, saying it comes from Burgundy. In Burgundy, we call it Morillon, Noirien, Pinot Liébaud. Morillon is a confusing name because it was given to different varieties. Noirien is more precisely given to Pinot Noir, and is the name given to the whole family. In Champagne, of course, Pinot Noir, very important, called Plan Doré. In Jura, it's called Savagnin Noir. It's confusing because Savagnin is Traminer, but you will see in a few slides why it is called Savagnin Noir. In Orléans, it's called Auvergnat, Touraine, Orléanais, etc. So every time it travels from one place to the other, it takes the name of the previous place. It's a bit confusing, but you can, throughout history, follow the path of the grape propagation. Germany, as I've said, also Blauburgunder, Blauer Herbst, Klebrot, Keck-Burgundy in Hungary, Chardonnay in Moldova, Switzerland, USA, etc. So you see many names for this grape, and in many different places because it used to be widespread all over Western Europe. Chardonnay is more simple. Chardonnay, you have Klevner or Pinot Blanc Chardonnay, as I said, and in different French regions, various names like Gamay Blanc, you'll see why, Melon d'Arbois, you'll see why, Chardonnay, Beaunois, Beaunois means from bone, etc. So now I go to the genetic part. So what did we discover with this DNA profiling and DNA parentage analysis? And my question, maybe you already have a clue, but back then it was completely unknown. Who knows Gouais Blanc? I can tell you that 20 years ago, almost nobody knew what it was. And then you can tell without Gouais Blanc, you cannot have your everyday Romanée Conti Montrachet, because of course it's made of Chardonnay. And it was found in 1999 by my colleagues at UC Davis that Chardonnay is a natural crossing, spontaneous crossing between Pinot, most likely Pinot Noir, and Gouais Blanc. This was a big surprise because we knew that Chardonnay and Pinot were very similar. Chardonnay was called Chardonnay Pinot Blanc or Pinot Blanc Chardonnay. We knew that there was some similarities, but nobody had heard about this obscure Gouais Blanc. And this Gouais Blanc also gave birth to another child with Pinot, it's Gamay. So Gamay, if you look at this, has the same parents as Chardonnay. When you have the same parents, you are brothers and sisters. So Chardonnay and Gamay are brothers and sisters. That is why Chardonnay is sometimes named Gamay Blanc, because you can see the parentage, the family ties in the morphology. And going further, with this study, they were able to find 21 brothers and sisters. So all of the grapes on this slide are the result of natural spontaneous crossings between Pinot and Gouais Blanc. They have the same parents, they are brothers and sisters. Of course, the crossings happen in different places, in different times. Some of them are famous, like Chardonnay Gamay, also Aligoté. Melon, Melon is also responsible for Muscadet in the Loire, is also a child. Romorantin, a bit more obscure. Kniperlé in Alsace, etc. And some obscure stuff like Beau Noir, Bachet Noir, etc., etc. So this means that these two guys, these two parents, Pinot and Chardonnay, were around these regions almost everywhere. And many times they crossed together spontaneously, because back then people didn't know how to make artificial crossing. It's a bit complicated and nobody knew how to do that. So it happened accidentally in the vineyards, and it gave birth to these grapes. So this Gouais Blanc is really interesting. These are all the names that we have found for this grape throughout Europe. Gouais in France, Foirard, Gauche in Italy, Prévéra, Liseret. You have Hönisch in Germany and Austria. You have Belina Drobna in Croatia. We noticed that it was almost everywhere under different names, and it has already almost disappeared today. So this particular grape has given birth to a huge diversity of different varieties. With the same studies plus my own research, we were able to show that Gouais Blanc is the genitor, the parent. It gave birth to at least 80 different children in Europe. We said Chardonnay Gamay, but you can also find Riesling, it's a child of Gouais Blanc, Blaufränkisch, Furmint in Hungary, Jacquer in Savoie, Folle Blanche, which gives the Armagnac and Cognac, and so on. So the general picture of the wine in Europe today would not be the same without Gouais Blanc. This is fantastic to imagine. There would be no Riesling, no Chardonnay, no Montrachet, no Tokay, no nothing. So it had a huge importance, and it had children all over the place. So I used to call it the Casanova of the wine grapes, because it has children almost everywhere in Europe. So going further, the pedigree, my colleague Ferdinand Regner in Austria was able to show that between Pinot and Savagnin, there was a parentage. One is the father or the mother of the other, but he was not able to say which one. And maybe that one of them, Savagnin or Pinot, comes from wild grapevines. I have a question mark because this has not been confirmed. But there is a parent-offspring relationship between these two. But since the other question mark is missing, we don't know in which direction. For example, if I have my DNA, you only have my DNA and the DNA of my father. You only have this. You can say, okay, one is the father of the other one, but you cannot tell who is the father, who is the child, unless you know the age of the people. And usually the person who is 70 years old is the father of the one who is 30. The opposite is not possible. With grapes, we don't know how old they are. We don't know their age. So we know that either Savagnin is the parent of Pinot, Savagnin is Traminer in German, is the parent of Pinot, or the opposite, Pinot is the parent of Savagnin. In the first case, you have Savagnin. If you look at this diagram, you have Chardonnay, Gamay, etc., born from this crossing I showed you. If you put Savagnin here, you have child, grandchild. So Savagnin would be the grandparent of Chardonnay and Gamay. If you have this situation of Pinot giving birth to Savagnin on one side and Chardonnay Gamay on the other side, they are half siblings. This is, we cannot go further because for the geneticist, grandparent, grandchildren, and half siblings have the same genetic value, have the same parentage value in terms of statistics. So that's the situation right now. Then I will go quickly. It looks like it's complex, and it is. But this is a work I did in 2006, and I still have a headache after that. It was a nightmare of statistics. But I could show that based on the work of my colleagues, this would be another topic for a conference, the story and origin of Syrah. Syrah is a cross between Mondeuse Blanche from Savoie and Dureza from Ardèche. This side here we will talk another time, but Dureza from Ardèche is most likely a grandchild of Pinot. And on the other side, it had grandchildren in Trentino. But if you look at this, look at the generations. 1, 2, 3 generations. So Pinot is potentially the great grandfather of Syrah. And this was very challenging because it assumed their independent origins. And since this work, because people thought, okay, Pinot maybe comes from wild grapes in Burgundy, Syrah comes from Iran or whatever, we had in mind that all the grapes would come from long distance traveling. And by this, I show that no, they are almost all integrated in the same family. That's why for wine grapes, we published this complex and comprehensive pedigree reconstruction with 156 grape varieties in one single family tree. Of course, it's very small. I did it on purpose. You have the address on top, winegrapes.org, where you can download the PDF for free, and you can zoom in and see what's going on and maybe learn some stuff that you have never heard of about these parentages. It's for free for anyone. But what we observed by doing this is that varieties like Pinot, but also Gouais Blanc and also Savagnin are involved in many different crossings. And we called them founder varieties. And we observed that most of the varieties that we observe, the diversity that we observe today, come from a limited number of varieties. We have identified 13 of them in Western Europe that gave birth to hundreds of what we cultivate and drink today. So that was fascinating to see. But, and I will finish, I hope on time, I still have a few slides coming back to the concept of grape variety, and I find it very important. If you look at Pinot and you ask a grower, what is Pinot Noir, Pinot Gris, Pinot Blanc, he will say 3 different grapes, 3 different varieties, because when I cultivate them, I see the differences. The wines are very different, 3 different grape varieties. And I say no. Geneticists and ampelographers say no, because Pinot Noir once mutated its color into Pinot Gris and once into Pinot Blanc. I should add an arrow because we have also observed Pinot Gris becoming Pinot Blanc recently, a few years ago. So at the beginning, you have this, and you have a mutation that is only a color change. It's nothing. All the rest of the DNA is the same. It's only a color change. And here you have the same for Savagnin, Savagnin Blanc, Traminer, that became pink, and with aromatic mutation became Gewürztraminer. This could also be the topic for another presentation. But what do we have here? We have a diversity that is within the grape variety. And I hate when I read all the time people speaking about the Pinot family. No, it is not a family. No. If you take Pinot, Gouais Blanc, and Chardonnay, yes, this is a family. Parents and child, this is a family. This Pinot Blanc, Pinot Gris, Pinot Noir, Pinot Meunier, Fruit Burgunda, which is Pinot Précoce, and also Pinot Teinturier, they are all the same grape variety that had accidents in its life. Because it's so old, it had time, and it's so widespread, it had time to accumulate accidents. But they are one and the same grape variety. And for people who don't believe me, they all have the same DNA, except at these positions where the color is determined, but they all have the same DNA. And if you don't believe me, look at this slide. Would you tell me that you have 2 different grape varieties in the same bunch? I don't think so. So here you have mutations. This is a Pinot Noir mutation, Pinot Gris mutation. This is what we call sectoral chimeras. It depends on where the mutation occurs. You can have berries that are completely white, others that are completely red, some half white, half red. And here, even a quarter gris 3/4 white. So this is evidence that these colors are only mutations of the same unique grape variety that is Pinot. Okay, Meunier is a bit special. Meunier is Miller in French because this particular type has hairs on the leaves, and these hairs look like you have flower on the leaves, and it has been identified last year where this mutation occurred, and Pinot Meunier is only a hairy mutation of Pinot. Sadly, I would say, the same year, the people in Champagne renamed Pinot Meunier into Meunier, saying that it is a distinct variety. This is wrong. This is a false allegation. This is fake news, like somebody would say. It's not true. It's the Pinot Meunier is a mutation of Pinot, but it's still Pinot, not a distinct variety. These changes occur also in Chardonnay. We have observed and cultivate Chardonnay Rose. We have also Chardonnay Musqué. I didn't put a picture because you don't see on the picture, but it has a muscat aroma, and many wines are made out of this mutation. And Melon à queue rouge, it means that this part, the stalk here, is red. We don't see it very well in the picture, but it's only mutation, but it's still Chardonnay. So this shows that it has, these two varieties have a big diversity. Pinot Noir is very, very old. We know more than 1,000 existing clones. Here are a few examples. At the moment in France, I think 47 or 48 of them are authorized, but many others exist in the old vineyards. Chardonnay is a progeny of Pinot. It's much younger, so the diversity is not as important, but it has been cultivated everywhere. So it had time to accumulate accidents, mutation, and we have around 150 existing clones with today, I think 28 authorized in France. This topic of clonal diversity and how we do clonal selection versus massal selection would be also the topic for another presentation. Feel free to ask me questions. I think I'm right on time to finish with my presentation, and thank you for your attention.
José, thank you for the presentation. To answer the first, even not asked question, yes, you get the presentation slides. You will get an email from us tomorrow morning with the link to download a PDF from the presentations. And now we have time. Is someone here who would like to ask a question? Just unmute your microphone and then ask it to José.
One question from my side. My name is Joachim Kaiser. You mentioned the three basic European ancestors of our grape varieties, Pinot Noir and Chardonnay. What about Muscat?
Yeah, Muscat is a big question. We also speak very often about Muscat family. Genetic studies about what we call Muscat family showed that many group of varieties that are considered Muscat are completely different genetically speaking, and they are not in the same family. They only have this similar aroma that can occur by mutation. We have Chardonnay Musqué that has nothing to do with Muscat Blanc à Petit Grain, for example, that is cultivated in Frontignan, for examtle, or Moscato Bianco from Italy. It has completely nothing to do. I live in Switzerland where we cultivate Chasselas, nothing to do with Muscat, and we have a Chasselas Musqué that had this mutation. So what we call Muscat family is not a real family. It's a group of many different varieties from different origins that have a convergence of the same aromas.
I have a question which was written to me from someone. José, how do you decide whether a mutation is a mutation of the variety or it is a new variety?
Aha. Aha. Excellent question. I decide. That's it. No, this had been the subject of much debate. The modern concept of grape variety, and I share this concept with people like Jean-Michel Boursicot, who is one of the best ampelographers in France or in the world, and Thierry Lacombe, Anna Schneider in Italy. We all agree on this definition that one grape variety comes from one single seed. And to have a new grape variety, you need to go through sexuality. You need pollen fertilizing pistil, having a grape pip, and plant it. If you don't agree with that, and you say, oh, if the mutation is spectacular, it's a new grape variety, then okay, you will say Pinot Noir has become Pinot Blanc. I decide it's a new grape variety. Okay, because for you, the color is important. But let's say for me, the enzyme XYZ is very important and it has mutated. I want to make it a new variety. Well, where do you put the limit? Where do you decide that a few hairs on the leaf, that is the result of mutation, is important enough to make it a new variety? Or if it's late ripening, much late ripening, or much earlier ripening, I make it a new variety. Where is the limit? It's too subjective. So the limit is to have a new variety, you need to go through sexuality. So you need to plant a new seed. And in all the research centers where they create new varieties, they do like this. They take the pollen, they put on the pistil, and they plant the pips and they look at the results. Nobody is creating new varieties by mutating them. You could use, I don't know, X-rays or UVs to try to mutate them, but nobody does that. It's only through crossing.
Okay, I have another question for you. Is Pinot Noir less genetically stable than others, or does it have lots of clones because of its age?
Excellent. It's also a question that we debated, especially in wine grapes, because we have read many times that Pinot Noir is more prone to mutations than other grapes. There is strictly no scientific basis for this assertion. There is no reason for Pinot Noir to be more or less stable than any other grape. It's only, as you said, as you put it correctly, it's only much older. If you look, let's say you look at Müller-Thurgau. Müller-Thurgau has been created in 1882, and you look at vineyards of Müller-Thurgau, they are mostly homogeneous. You don't see much diversity. It starts after 140 years to develop a few different forms, but it's still quite homogeneous. While Pinot is probably around since 2000 years, and it had, it's widespread everywhere, it had time to accumulate mutations. So it looks like it's more prone to mutations, but it's not, it's just much older.
Another question is coming from Andrew Shefford. He asked, when we try Gouais Blanc today, it seems to be a quite boring variety, making quite boring wines. So why was Casanova so successful? Why did it end up all over Europe reproducing like crazy?
Yeah, this is a complex question, but I'll try to answer it. So indeed, when you try wines of Gouais Blanc, they are not really interesting. I've had a few of them. Very few producers are continuing with this variety because it's very high in acidity. The yields are very high. So if you don't prune it and if you don't lower the yields, the wine is almost undrinkable. In places in Switzerland where it's still grown, there is a story saying that people, ancient growers would plant it around the good vineyards to keep away people from stealing the grapes because it was so bad. So there were two types of wines and grapes in the Middle Ages, the Frankish and Rhenish. The Frankish was the grapes similar to Pinot that were considered noble, giving good wines, but with low yields. And the Rhenish was the grapes for the Huns, for the barbaric people, for the poor people that were giving high yields, but low quality. And Pinot is a Frankish variety and Gouais Blanc is a Rhenish variety. And they were cultivated together for different purposes. So they had many times the occasion to be side by side in the vineyards and to cross-fertilize, to exchange pollen on the pistil of each other. And why the result is so good? Well, I don't know the parents of Einstein, but probably they could have been stupid. It's not impossible. This is what we call the heterosis power. When you have two parents, if they are too similar genetically, the result is not good. The worst case, if you have, if a father has a child with his daughter, which is of course shocking, not in grape varieties, but in humans, of course the result is not good. The result, the child would have a lot of diseases and might not survive. It's the same with grape varieties. But if they are distant enough, genetically speaking, one side of the genetic of Pinot and one side of the genetic of Gouais Blanc would mix together so well that the result is fantastic, and the result is Chardonnay. So this is what we call the power of heterosis. Hetero means different. So if the genetic is different enough, the result can be good.
I have two questions written left on my side. Is someone on the line who would like to ask a verbal question?
Yes.
Then I continue. If you plant two seeds from one grape, do you get two new varieties? And if so, what is the relationship to the grapes that the seeds are from, and who are the parents?
Okay, so today that we have vineyards that are dedicated to one variety, most of the growers have one vineyard of Chardonnay, one vineyard of, I don't know, Syrah or whatever. You have two possibilities that can occur spontaneously in the vineyard. Either the pollen from the vine that is 1 or 2 meters away arrives on the pistil, or the pollen of the same vine, the same flower, arrives on the pistil. If the pollen of the same flower arrives on the pistil, this is self-fertilization. With self-fertilization, it's like, let's imagine, what I will say is becoming horrible. Let's imagine that I'm hermaphroditic, that I'm male and female at the same time, and let's imagine that I can fertilize myself and become pregnant of myself and have a baby. Yeah, the result would be a monster, I agree. But it would be a different individual. It would not be me. If I do the DNA, of course it would be very similar, but I could see, no, it's not José Vouillamoz, it's child. And I can tell you, he had the child all by himself, which is highly not recommended. In grape varieties, I think this is what happens. I would say, we don't have the numbers, but maybe 95 or 98% of the time, it's within the same flower, the pollen that falls on the pistil and that fertilizes it. Why? It's because if you, I don't have a picture of a grape flower at hand, but I could show you. When you have a flower of a grapevine, you have the petals that are stuck together on top of the stamen with pollen and pistil. And stamen can become ripe before this petal cap is removed. So most of the time, it's the own pollen of the variety of the flower that is fertilizing pistil. Most of the time, we have self-fertilization, and this is why we have good harvest every year. If you had to wait for a different variety to pollinate it, we would not have harvest most of the time. So either you have this, or if it's the neighboring vine, usually if you have a vineyard of Pinot, next to it, it's Pinot. So it's the same result. You have Pinot per Pinot. So to answer the question, yes, these two seeds, if you plant them, are two different individuals. Both are most of the time the result of self-fertilization. They would both have their own DNA profile, but they would be very similar to the parent.
Yvonne asked you, José, you talked about the clone as being a human concept. Would you rather talk about plant mutation than clones?
No, because plant mutation can occur anywhere in the DNA without having any effect. Big portion of the DNA, we don't know exactly the number, it depends on the species, serves nothing. At least we have not identified what is the use of it. This is what we call junk DNA. We don't know why it's there. Maybe it's the relic of evolution. So if you have a mutation occurring in this junk DNA that we think is for nothing, it will not have any effect. Yet it is still a mutation. So what we call clone is a spectacular mutation.
And the final question from Ina Finn, do you know whether the development of grape varieties has changed with grafting and in brackets in case of mutation?
So the idea behind the development of new grape varieties, if I understand well, new grape varieties, because the traditional way has been almost completely lost everywhere. I mean, spontaneous, accidental crossings in vineyards today is not possible because everything is so clean. So when we create new varieties in research centers, most of the time we try to create varieties that are resistant to some diseases. So the choice of the parents is based on these parameters. It must make good wines and be resistant to disease, to drought, to cold, spring frost, and so on. Grafting has no influence at this point. But depending on your choice of clone, the choice of rootstock to which you will graft your vine is of utmost importance. And this could be, I will attack this topic maybe next time when we speak about Grüne Veltliner. The choice of rootstock is one of the most important field of study for the next 20 or 30 years, also related to climate change, but this is a bigger topic.
Okay, the last chance for you to ask a verbal question, someone who
Yeah, I'd like to ask something.
Yes.
So there are some varieties who has only the woman flower, so without the pollens. How did they determine which varieties can fertilize them?
Yes, you're right. A few varieties, I'd say less than 1% of the existing varieties are female, what we call female only. For example, Picolit in Friuli in Italy, or Maratheftico on Cyprus, for example, that come to my mind. A few other, Ojanes in Spain. What happens if you look closely at the flowers, they have the pistil, that is correct, and the stamen start to develop and we call resupinated. They change direction, they go downwards, and they don't produce any pollen. So these varieties cannot self-fertilize, cannot fertilize themselves. And you need to plant next to it a normal variety that is producing a lot of pollen. And ask these people on Cyprus or in Friuli, if you don't plant something that is producing a lot of pollen very close to it, you never have harvest with this variety because pollination is not occurring. And if pollination is not occurring, of course, the pistil, which contains the ovule is the female part of what will become the grape pip, the baby. If it's not fertilized, it dries out. So you need fertilization for the berry to develop. And as I said, most of the harvest we have all over the world every year is thanks to this self-fertilization. That's why these examples are very, very rare.
Perfect. So José, thank you for your presentation, for your slides and answering all these questions. Maybe we see some of you again next week at the Grüne Veltliner session. We are planning for next year, maybe Cabernet Sauvignon Merlot, Syrah, and as an Austrian, of course, Blaufränkisch. And we will send you the invitation there. Tomorrow you get an email with the link to download the presentation and the replay function. And please don't forget, if you're looking for mature wines across the world, consider mywines.com as well. Thank you and have a good afternoon.
Thank you very much. Thank you. Thank you all.